Doctori, tutto a posto? Welcome back to a new episode of Sane C Libraries. That is a set of C++ platform abstraction libraries for macOS, Windows, and Linux that focuses on fast compile times, being bloat-free, simple, and readable. Easy to integrate with no use of the C++ standard library and no third-party dependencies. So make sure to check it out on GitHub and take a look at all of these beautiful libraries. Some of them are draft, some of them are MVP or usable, but you can enjoy them anyway. And you can get in touch on Discord or Twitter, Mastodon. I think I even added what's the name of the social network? Blue Sky? We'll see. I need to add it here. Anyway, then that being said, let's see what are we going to do today. I guess today will be a continuation of what we have done in the previous videos. We have been taking this Node.js asynchronous programming abstraction called the streams, and you can see here. This abstraction allows us to create readable streams and writable streams. They are asynchronous streams in the sense that you can describe operations that are asynchronous, like reading from a socket. And so these operations can happen in parallel and you can pipe them. The Node.js also has a concept of a transfer stream, which we are not attacking yet for now. But we have created the readable stream, we have created the writable stream, which are here. Yes, I actually took the time to comment everything and put them in a dedicated file compared to the latest videos. And so this will be what will be pushed on the GitHub repo. Just, same stuff of the video, a little bit commented, because we want to know what's going on in all of this state machine. And yes, so this is the plan. I would like to create an async pipeline. So the async pipeline will be something that takes a readable and a writable or multiple writables, and it's like piping them. Then I would like to create this request read stream. It should be able to use like sockets and files. Maybe you should make it template, probably yes. And the same for the write stream, which again can have a socket as a destination and a file. This will use the C Async, requests to achieve the socket and file writing. And then I would like to write a file-to-file test and a file-to-socket test that then will be socket to file. So this will be like a single pipeline. This will be two pipelines that are chained by the fact that the two sockets are connected. That's a lot of work. Let's see what we can get done. So I have a plan. So this looks like a plan. Let's start with the async pipeline. So let's say async pipeline. Our async pipeline needs to have, actually, maybe I should put it into a test. You know what? Let me create a test for it. Where is it? Open. Test. Oh, libraries, async. Tests. Let's say we make async request streams test.cpp. That could be good. I can just copy the beautiful copyright. And let's start to include async and async stream, testing. Probably we're gonna need all of this stuff here, but yeah, let's take all of them. Eventually we'll remove it. I should probably prepare all of this infrastructure so you don't, you person who's looking at this video will not waste time looking at me just editing some completely useless piece of text. What do you think about it? Maybe you could write something below in the comments. and that will be very helpful. Or maybe you can say, no, I just like to see all of this multiple cursor editing. And in that case, I can continue doing it. So we can say file to file, file to file. So this is AsyncRequestStream tests. Let's go into the sctest.cbp, run async test, async stream test, and then we have async request stream test, because now we're going to use the requests from C Async. That's why you see all of these words that have some actual meaning to it. All right. So I can say a C async request stream test file to file. Yeah. Make void, and I can declare it here. File to file. Then I should regenerate the projects using this project. For the ones that are not following it, it's using its own build system, which is bootstrapped using the library itself. It's a build system generator, so it generates files for Xcode and Visual Studio and make files. So yeah, we are able to break here, so we can actually start. Struct async pipeline. This pipeline, what do we need to have? Probably we will need to report errors coming from sources and destinations. So we can have an event. Of course, this needs to be into the Sane C++ namespace, which is SC, incidentally, not SCPP. Anyway, event max listeners. Error as a result parameter, event error. So we can say static const exp int max listeners equals, I don't know, 5. I've been counting how many, I don't know, I have been saying in like previous videos, because I've been watching them to see, you know, how they were going, and I say way too many, I don't know. But that's the reality, I don't know. Now, I need to have an async readable stream, which is my source. Then I need to have a span of async writable stream, which are sync. Probably I should make it like a struct destination, so I can, yeah, or sync, yeah, maybe struct sync. So we have source and sync. I can have the writable stream here, so I can add also transform stream, or maybe a trail of transform streams. Yeah, let's call it sync, node ptr. And I can have a span of sync that are called syncs or destination. I don't know. I don't know. I just don't know how to call things when I'm creating them, and I keep refactoring them big time. And I think you may be able to see it, because these names are not always matching what you see on things that are being committed, because I always take some time to refactor and clean up. So I can init, should I be able to init this somehow? Let's see, if I have an async readable stream, okay, and I have an async writable stream, how should I configure this pipeline? Async pipeline, my pipeline dot source will be my readable, and my pipeline dot destination. I need a buffer, a user allocated buffer of destination. So I have a sync pipeline, sync destinations, which now it's just one. So my span will be destinations and will be one, right? And my destinations one, actually 0 will be my writable. No variable overloaded. Why? Yes, because I need the sync substruct field. Now this looks like, yeah, this looks decent. I need to have a start. So I can start it. I can say pipeline.start at some point. And I can, what should I do in the init? Well, I need some init, right? Yes, result init. In the init, I should be taking the source on data event. Yeah, the event data, and I should bind it. Should add a listener. Oh, I even have the syntax to directly bind like a method, a class method. So this can be on buffer read. And this can be our private void on buffer read. And on buffer read, this will take, it's event data. It's, emitting an async buffer view ID, which is the parameter that gets passed to this listener. Ignoring return value. So this needs to be tried. Return result true, of course. Too many arguments. Oh, you know what? When you have this macros and you have template symbol in the middle, you need the double parenthesis not to break the macro parsing. That's, macros are not so good here in C++, but what can we do? That's the best thing we have so far. Actually, this try macro is just doing like if not something, return the error. But yeah, I like having one line for that. It looks like other languages like, Rust like type of try and return the control back to the caller when something fails. Then I can have on buffer written, so I can loop over all of my syncs. So say sync, destination. Maybe I should call it destination. Sync, event. What do I need? Event drain. Yeah. Maybe on the event drain, I should like resume. So async pipeline on drain. Let's try. In the real sense of try. Of SC try. Do you mean async pipeline? Yes, that's exactly what I mean. I mean exactly async pipeline. A member named on drain. Yeah, because I can put it here. And that's my own drain. I think I need to check also that, yeah, the sync .sync .get buffers pool. If this is different than the source buffer pool, that's not going to work. Or will it? Well, for now, I want to return an error because I'm not sure if things will be working properly without this constraint. So let's say return result error source, and things must have the same buffer pool. All right, so the start should be just doing source.start. Yeah. So once I read something from the buffer, I should loop all of the destinations and say sync write destination buffer ID. I should probably, yeah, that's exactly why I'm putting this constraint, because I need to pass the buffer ID from the source to the sync, so they need to share the same buffer pool. Otherwise, a buffer, as we're just passing an ID and not an actual like a buffer with ownership that needs to be known to the pool. So we can say we definitely need to ref buffer the pool so it doesn't get garbage collected. And then I'm not sure if I need the train here. Let's see. So here I need to create a function that I need to pass to the write method, right? What is the signature of this write method? I think I remember, but just, yeah, it's just a function void async buffer view ID. So let's take it. Copy, callback. So callback dot bind. I think the syntax is the same as here. This is a function. It's an std function like object, actually more like function ref. It doesn't allocate. Not really sure exactly what are the constraints for the function ref that is probably being proposed on the standard C++. But we don't care. This project doesn't really use the C++ standard library, so that's going to be fine. Whatever they do, they will be good. Instead, we will need to try doing this. Returning result here for sure to avoid this error. And I also need to understand why this is not working, and it's because the parameter needs to be on a buffer ID. So here I need to collect the result. This is an event handler, so I cannot just return a result. It doesn't work. So that's where I need to call the event error. If not res event error emit res. And what am I ignoring? Oh, this one. Test expect. This looks good. So in the buffer written, once I'm writing something, once I'm done writing something, well, if allocation fails, I actually don't even need the train event. Yeah, I don't need all of these. because when the buffer, basically when the readable will fail, as the pool is common between readable and writable side, at some point, if the write queue will be full, the pool will just stop giving buffers to the readable, which will go in pause because there is get buffer and pause. If you remember from the some video ago, was it like, no, it was 2 videos ago probably, sync readable stream, there is this get buffer pause. So when the request new buffer fails, it will just pause. So what all I need to do is source resume here. Of course, I need to free this buffer that has been graphed here. So I can free it to just like ungraph buffer and try to resume. Hopefully resume will be good. Will only be erroring out in stopped and error state. That's all right. And in ended. Maybe ended should also emit error. But I don't know. Well, I don't know. We'll see. All right. So this is probably useless. So this can just become a return this thing. But let's keep it like this for now. So more or less, that's what the async pipeline needs to do. So not very long. Of course, I probably need to add a stop, pause method also here. But I want to keep it simple for now. So that's going to be okay. On Node.js, this is not done through an object. You literally, I think it's, I remember because I have been reading the implementation. It's like chaining all of the data events, pipe events, and creating a network of events that probably plays well with the garbage collected nature of JavaScript. But I think for how this framework is being developed, and it's very C++ centric and very, even the style doesn't try to use, there is like explicit ref counting, doesn't really make sense to replicate that. So I think a dedicated object will be better. Now we need to create this AsyncRequestReadStream. So the point of this AsyncRequestReadStream is to be able, it basically needs to be a readable stream. Yeah, I mean, I'm inheriting. That's not strictly necessary, but I think it fits well because we are not using virtual inheritance anyway. When creating this read stream, we will be taking the async readable stream, async read, and we will be assigning a function that is our AsyncRequestReadStream read, probably operation. That's how we want to call it. Yeah. I mean, this async read could very well be a virtual function, but I have a problem with virtual functions and I prefer events. The difference in performance should not be huge, especially for the frequency at which these methods are being called. I've not measured, I should be honest, but I don't think this will be so relevant. And we can always change them to virtual methods if we want at some point. So I have my read method. My read method needs to have the correct signature for async read, which is, guess what? Just an async buffer view ID, right? No matching member. I need to send the address here. What am I doing wrong? Async read. Oh no, this one returns a result. I don't remember anything. Okay, just result. What am I doing? That's not a lambda. That's a result here and return result here. Return result true. Okay, so we need to initiate the read here. So let's say we have one object from the async library. So async.h. This is our beautiful asynchronous.io library. Please check it out. That's really, I think it's a nice library. I have also plans to make it even better, but I think it's really good in its current state. It's basically kind of a self-contained replacement for a subset of what libuvu and Boost Asio is doing. So I think it's pretty powerful. It works on Windows, macOS, Linux, iOS. On Linux, it has two backends on UU Ring and regular EPOL. So it's a nice library. You can do this loop wake ups, socket operations, file operations, and even monitor processes. There is no handling of signals, so something is missing compared to the other two famous libraries, but I think we can get there at some point. So this is a readable, so this will be socket receive. So the point is that we want this request stream, the readable one, to map to a socket receive and a file read. So let's start with the file read. So I need to have an async file read request. All right. So my read will be request.start event loop. Okay. So this needs a result in it with an event loop, async event loop. The event loop, it's clearly the event loop of the AsyncIO library. So if someone wants to create this read stream, they need to give me this async event loop in order to initialize this file read operation. So I can say, I think I have a method where I can cache internal event loop. All right. And then I can start request event loop. So this cache event loop, internal event loop, it's basically saving the event loop into the async request. But this will be asked again in any case during the start. So that's just a way for me to avoid saving an additional pointer here that is completely not needed. So request dot on what's the event? It's called callback. Yes, callback. Callback needs to bind to AsyncRequestReadStream. AsyncRequestReadStream. AsyncRequestReadStream dot on data read. Does it sound good? I'm trying to avoid saying I don't know. Please just appreciate this fact that I'm trying to avoid saying it. Void on read. So this will be, so every async operation from the SC Async library returns sort of like a result object, which is called whatever it's the name of the request result. So this is our result object. And we are still compiling. And so we have result dot, well, I need to set up the request. Right, so I need to we are a readable stream, so we can get buffer pause, minimum size in bytes. We don't care, so we're just gonna pass 0. We take whatever buffer they are going to give us, because we can, with the file read, we can choose how much we are reading. So we are, whatever buffer you give to me, I'm gonna use it entirely. Buffer ID and the data. So this is our span of char data. So if get buffer pause, I'm going to start it. Otherwise, return result. Should we return error here? I'm not entirely sure. No buffers. Yeah, even error messages, I try to, make them more able to give more information of what failed, about what is failing. But when I'm like in the flow, in the coding flow, I'm trying to really say 2 words, so I can stay in the flow. I can go with the flow, if you remember that very, very nice song. So this will not be okay, because I need to save a buffer ID. So I think I will take the request callback and use a lambda, so I can bind my buffer ID. Yeah, so I can bind my buffer ID. So let me do this, and I can say on read. I can pass the result, but I can also pass the buffer ID. And this becomes my second parameter. I need to do this because otherwise I am not able to know which buffer has been read. I could be saving it here, but we have space in the callback. So that's one less 64-bit or 32, I don't know. I said I don't know. Integer, so here I have buffer ID and the result. So I can say if result get data. I can say span char data. I can set, let's say get buffers pool, set new buffer size, buffer ID, new size in bytes will be data size in bytes, because we may have read less than, maybe they gave us like a 1 gigabytes buffer, probably not, but let's imagine, and we only have been reading 2 kilobytes. We need to size this buffer. And if you remember, we have this way of remembering the original size of the buffer. So when this will get unwrapped, we will, gain back all of the unused memory. Otherwise, we have an error. So we can emit error, and we can say result dot return code. No. Oh, get returns our result. So let's do like this. Result res equals this. So if res, we'll do this. Set new buffer size. Otherwise, we return the error. Actually, we bubble up the error asynchronously. Yeah, this looks good. So now I would like, now there are two concepts that are overlapping, because I have added this concept of the reactivation in the in the async stream. If you see async stream readable, even in the test, we have this reactivate method. And this is basically something we need to call in order, especially for asynchronous workflows, in order to get the read operation called again. But this is not necessary in the sense that the state machine will accept multiple push without going into this reactivate. You can push as much as you want, and then you can push end. And the async C Async library has its own concept of reactivation. So that's kind of confusing because I actually copied the mechanism for async stream from what I figured out with the regular async library. But I think it would be more efficient to use the mechanism of the C Async reactivation, because that avoids one kernel call, because if you reactivate, like on, I think on epoll and key event, maybe only on one of the two, you will not, basically if you say I'm reactivating, that handle will not be removed from the kernel queue. So you have one less kernel calls, and that's a premature optimization, but why shouldn't we be doing it? So I can say result.reactivate true, but I can do this only if I'm able to I'm able to get another buffer. So I need to get buffer, but basically redo this, right? Redo this, but instead of returning with the start, I just need to reactivate. Yeah. So the get buffer pos will update the buffer ID. I'm reusing this variable. Should I create a new variable? That's probably a good idea, but yeah, let's keep this variable for now. So if get buffer pos, we'll get a new buffer. We'll just update the callback, so next time we will be back here with the correct buffer ID, and we reactivate the request. If result.end, do we have a disconnected on the file read end of file? I don't remember anymore. How do you know if you are end of file? Async test end of file. How can I know if I'm at end of file? Oh, use thread pool. I mean, there used to be an end of file flag somewhere. I just don't remember. Oh, completion data end of file. It's, not even me that I actually created and coded this entire library can remember. So yeah, that's why IntelliSense it's so fundamental. So if end of file, we should just push end. The result should be true. So we have probably something like this. Oh, there's a little bit of nesting here, but I think it's pretty readable. So you get the data, you have a good result, you do good stuff, otherwise you emit error. Then you say, yeah, there's good stuff, but it's end of file, yeah, push end. Otherwise, you set new buffer size, you push the buffer. Oh, actually, we have a new sides which is taking care of this for us. That's beautiful. Look at beautiful API. Look at this beautiful API. And let me add also this totally unnecessary prefix so I know I'm calling base methods, which is, you know, more clear, at least for me, or to me. So I'm pushing. After pushing, I definitely, well, I need to remember this get buffer pause is requesting new buffer, which is putting the reference count to 1 of all of these buffers. So you know what? Here I cannot even do that. I should do result if not result. I should unref this get buffers pool unref buffer ID, and I should be doing the same all over here. Before push hand, basically I will have like this buffer will not be used at all when I get end of file, so I'm just going to unref it. I'm going to unref it even when I'm hitting error, but I cannot unref it before here, like here, because I still need to push and then unref it. So then I will get a new buffer, or possibly the same. This will update the buffer ID. I'm updating my callback, so the buffer ID context will be different at this point, or maybe. And then I'm reactivating, so this will be called again automatically. Actually, this callback will be called again when there is new data. Yes, and this should all work. I need to set the memory here. Buffer equals data. And buffer equals data also here. Right? Actually, I don't even need this. Well, I need the data because I need the sides. Yeah. I'm updating the buffer, updating the callback, and reactivating. This looks something that could be working, but we will see as we go. All right. Let's try now to write the async request write stream. So yeah, this will eventually be done later. Let's do like this. You know what? I'm not confident I will be able to do this. So this will be probably done in our next video, because this is already getting very long. So that's, yeah, we will be stopping here. I always try to make too much stuff in a single video, and this is clearly not working. So let's say async request write stream. Async request write stream, async writable stream. So what should I do? Here I have an async write request. I will probably have a similar init with the event loop, and I have an similar method to connect myself or some method of this class to the write async write. So async write this async write. What's the signature? Oh, this IntelliSense navigation doesn't work. Why? Where is my write method? Async write. Oh, look at this signature. It's a long one. So we have a result, the buffer ID, and the callback. So it is Kawabanga. There's a famous meme that my friend likes, so I'm going to say it during this video. So this will be write, and async write will be just binding to this async request write stream and the method, the write method, on this object. So that's like Postman virtual function. Non-void function doesn't return result true. Okay. So we are getting a write request at some point from the pipeline, and we should make sure to just issue the request dot start on the event loop, which is again on the request itself, get event loop, and we can return this. So if I take a buffer ID, I will need to get buffer spool, get data from this buffer ID and the data. So this will be a span of const char data. So if get data, I can say request dot buffer equals data. Otherwise I can return result error like no data. And also here result res, and if not result, Oh, I can do like in the opposite way. So if I'm able to start the request, I can take ownership of this buffer ID, not taking ownership, let's say avoiding that this is getting garbage collected. So I can get buffer spool ref buffer ID, and I just return result, whatever it is, good or bad. All right, so my callback will be after write or something like that. Async request write stream after write written, buffer written. Please leave a suggestion below. Void after write, and this in the same way as every other C async callback function is just name of the async file write request, result sub class object. So that's our result. Clearly, if result get written size in bytes, yeah, this needs to be a result. If result, all good. If not result, event error dot emit res. And I think we should be in state error at this point, but I'm not sure if we do have a method to set that. We don't even have the error state. Yeah. We probably need an error state here. So this event error should be like emit error, and it should be moving to error state. But I think this is some level of taking care of details that I will probably be fine-tuning as we go, and maybe as I write some more advanced tasks, maybe testing error conditions. Now we're trying to do like the good case, like, okay, things are kind of working, and let's see if we can get it to work. So in the after write, I definitely need to undraft the buffer once I got it. And I don't have the buffer ID. Oh, I even have the callback here that I need to save because I need to invoke it and call finished writing with this callback. So, yeah, I need to save it here. Thankfully, I know that the callback will be, this write will be called just once until I call finished writing. I still need to bind the buffer ID in the same way as I did here, right? Yeah. So let's say request.callback. It's my lambda. I'm taking the this pointer so I can call a method on this object, and also the buffer ID by copy. This will still have this parameter as the first parameter of the lambda, and then I can call after write with the result and the buffer ID. Too many arguments. No, there are not too many arguments. I just need to add one. Well, they are. Async buffer view ID, buffer ID. Yeah, we have the buffer ID. I have the callback, and I can say async writable stream. If you remember, we need to call this finished writing with the buffer ID, with the callback. Oh, we even have the result one, so I can just use it here. Good, so when we will be updating the state machine, this class will work. Even if we decide to put the entire writable stream in an error state, that will still be working. You know what? I could just do like, well, that's all right. Yeah, this looks decent. Well, maybe I should undraft this buffer. Use of undeclared identifier callback. Why? Oh yes, it's this one. Let's do like this. So callback equals CB. Error value reference. So should I move it? But I think this will get invoked again. Should I probably copy it? Like auto callback copy equals, well, actually it's not copy, but yeah. Yeah, I should probably remove it because I think this is reentrant. This will call back into write. Yeah. So callback, you can set it to null and then move the copy we have on the stack. Callback copy. Yeah. All right, so let's try to open a couple of file descriptor, read descriptor. Yeah, let's try to write this test now. File descriptor, read descriptor. File descriptor dot open path. I should generate a path. String readable path. Path dot join readable path. Report dot application root directory readable dot txt. Then I can open this readable path. I can say file descriptor, open mode, write, create and truncate. Test accept, expect. Sorry. No matching member function because we need a view, right? Yeah. So that's our readable with the read descriptor, and we can do the same. Open mode. So we first need to fill this readable file, maybe even close it, right? How do I fill it? Let's create like a vector of uint 64 buffer all data reference data. Reference data, we can resize it to be like a kilobyte. We divide it by size of uint 64, so I can loop I can loop like this. Let's do it uint 64. Can I spell it proper? uint 64. Yeah, no, I cannot. Reference data idx equals idx. We are going to be able to allocate a kilobyte, so yes, test expect. So I need to write this file first before opening it. So let's say, let me generate the name first. Then I can just, file system fs dot write. Oh, the cat has decided to just start doing the cat. So reference data dot span to span const, and the file is readable path. So I'm creating this file. No matching member function. We need a view. No matching member function. Oh, it needs to be receiving a span of const char or const uint, so we can reinterpret as array of const uint 8 or const char. Okay. Now this is yeah, I should probably create like a templated version of this one, so I don't need the reinterpret. But for now, this is fine. So I can open the read descriptor and create the writable write descriptor. So the idea is that I should be able to create the pipeline. Yeah. Create pipeline. And then I should be able to read the written file again, probably just using fs dot read file is our writable file, writable path dot view into some vector of data, yeah, vector char writable data. So here I would like to check if I've been able to route all of the data properly. Expect. So I'm reading all of this data. All right. And then writable data to span const reinterpret as array of const uint 64. So this will be my span of const uint 64 written data, and then I can expect that written data dot size in bytes is the same as my reference data, which I can keep it outside of this scope. So yeah, let me remove the scope, or I can do like this. My reference data to span const dot size in bytes. Then for uint 64 idx, actually now this can be just a size d. idx less than written data dot size in elements, size in elements. idx, I can say written data idx needs to be equal to reference data to span const idx. Bool is values okay is true, values okay is values okay, and yeah, something like this. And declare identifier values okay, and I can expect that values are okay. This will segfault if they are not the same, but yeah, we will be stopping at this assertion first. If the size of the two arrays will not be the same, this will of course segfault. Yeah, this looks something we can try. Where's the pipeline start? Let me, yeah, maybe I should create the pipeline later. Create pipeline, pipeline start. Yeah. So the async readable stream needs to be an async readable request stream, and this needs to be a request stream as well. Oh no. Oh, the request, yeah, sorry. Wrong naming. Async request writable stream. Async request readable stream. Write stream. No, it's writable. I mean, can I name things properly or not? Okay. This is not named properly. Why? Okay, now they have proper names. Actually, read stream, write stream could not be that bad as name, but yeah. We'll see. So the point here is I need to initialize my event loop, async event loop, and then I can test expect event loop dot create. So I can say readable. I can get my descriptor. Let's say read descriptor. Yeah, I should be probably passing the descriptor to the init. So readable.init, event loop, and read descriptor, right? Yeah. So let me add this to the init. File descriptor. This becomes result because I will need to do descriptor dot get handle, which becomes request dot file descriptor, result error, wrong no descriptor. So we are getting the file descriptor from the operating system file descriptor, which is this one, the handle, from this file descriptor class. Return result true. So we can expect this, and the same also for the write stream, right? So file descriptor here. This can become a result. I can say file descriptor dot get request dot file descriptor result error no descriptor. We can try this and return result true as usual. So now I can say writable init write descriptor. Which I don't have because it's later. It should be like file write descriptor. Yeah, I should rename this, but yeah. Okay. It looks decent. So I'm initializing this with the proper descriptors. Well, I first need to, this is the final check, right? Yeah, final check. We need to run the event loop. Yeah, so let's double check everything. We generate some data here, okay? Generate test data. Create the event loop. Set up async event loop. Then I'm creating, Siri just likes to wake up sometimes. Creating the read and file descriptor, read and write descriptor. Actually, this is writable. And so basically creating opening two file handles, and these two file handles, we will open one. We need to open actually read only. And then the other one we create in write truncate mode. We initialize the two streams, we create the pipeline, we start the pipeline, and then we run the event loop. Where this at some point will finish because there will be no more requests, and we check if all the data we expect in the writable file. So probably we should also close the file descriptors here. Yeah. Write descriptor and read descriptor. So I can open it again, read the data, and check that it contains the data from the source, the generated test data. Pretty simple test. Generate data, write to file, read the file, pipe it into like a destination file, read the destination file, check that the data is correct. Let's run it. Run. Boom. We are already doing something bad here. Oh, because this is already a uint. All right, so we have less than 1,024 uints. Yes. Okay. No descriptor. So we have no descriptor from, yeah, because I'm closing it. Why am I closing it? Okay. Start. Can start only in can read state. Oh, because should I call init also here? Yeah, we also need the buffer pool and the request. I completely forgot about these two guys. So we need to give to basically, yeah, we need to be passing this to the stream classes and call their init method. Init buffers pool requests, and the same also for the readable. Yeah, why not? Too many arguments. Yeah, I need to prefix it with the base class name, so the compiler understands who I want to refer to. So now I need to do async readable stream request readable requests, which can be 2 writable requests. That can be, say, num-buffer static const. Well, we need something similar to the previous test, at least the creation part, something like this. Yeah. So I'm creating buffer byte size. No, I want this to be 16. Let's try. So we have the buffers, we allocate the buffers, we slice them, and we have our pool. So we have readable requests. So the pool does exist, and we can say pool readable requests. So we need to make it number of buffers +1 and number of buffer +1, because only one slot will be left, not used by this is used by the circular buffer thing that we coded in some previous videos. So yeah, so I need to also do this writable requests. Yeah, thankfully they are properly yes, because I've made it readable stream, this needs to be writable. This looks a lot better. Run. Final check. We cannot even read the file. So is it even creating files for us? Let's see. Build. Where is this running? This is running in Xcode. I don't remember where it is running. Outputs. macOS readable. So there is nothing in a readable. That's not so good. Are we even writing this? And this should be writing it, right? Readable. So if I delete it, let's say, right. Is this the path? Yeah, readable.txt. Oh, now this open anyway. Hex editor. Okay, we have some data. I don't know what was going on. Am I maybe overwriting it at some point here? So we have all of the buffers. So I'm opening in read only. Oh, look here, write, create, truncate. Yes, because I'm opening the readable path, not the writable path. So I was creating the file and then just deleting it, destroying it. Let's try again. So this is creating our file. Should be able to open, let's say here. Now we should have both files. This one should be empty. Perfect. I'm creating the pipeline, starting the pipeline, running and closing. This works. And then, of course, written data is 0. Now we need to debug. But, the test looks set up in the proper way. How can we debug? Let's see. Are we getting the buffer read callback called? No, not even that. Oh, is this started? Start, execute read. Are we going into the read here? So this is the read for our request readable stream. So we get a buffer, we set it, then we start, File descriptor is set up, the buffer is set up, the callback is set up. Oh, this should kind of work. Let's say, yeah, we get the onRead call. Result is even good, so we are pushing the data. So when pushing, should be landing somewhere into the pipeline object such that we are routed here. Why is this on buffer read disabled? Okay. Oh. We are not getting written. That's interesting. I would be, so let's see what's going on in the push. Push sets the buffer size, pushes back, refs the buffers, emits some data. And we are listening to the data event, right? No. What event are we listening? Sorry. What am I doing? Oh, I have not called the init on the pipeline. Yes, so this is not getting registered. So maybe, yes, adding some checks so that we are sure to call init. That would be great. So we start, read, onRead, push, on buffer read. So this gets on all of the destinations, right? So should be able to arrive here into the write. Write is writing, setting the callback, asking to write this data. And as we are not specifying the offset, this is just appending it, hopefully, to the end of file. But we will see. After write, unref the buffers, checks, moves the callback, calls the finished writing. Yeah, let's go. So written data. We have been able now to write something. No. That's clearly not what we wanted. And it's also 0, 1, 2, 3. So we are stopping after a while. So the reason could very well be because we are not unreffing things properly. So, maybe I should I unref after or before finished writing? That's interesting, because finished writing will not be doing much with this buffer ID, right? Why am I even sending it? That's weird. This parameter is totally useless. Yeah. So I can release it before even calling finished writing. So I think at some point we are getting paused, right? Because this fails. Okay, which is expected. So we are not getting resumed. because the after write, so we are not getting the pipeline resume is not resuming. Are we ever arriving here? No, that's our problem. On buffer written, oh, we're not passing the callback. I guess this could be a reason why we're not getting callback called. Move callback. And then we are also exhausting the buffers because we are not unreffing them. So yeah, not good. Let's see. Beautiful. That's amazing. I'm actually really happy. So yeah, let's recap what has been done. So let's see. These are our notes somewhere. I have done only half of what I wanted to do, but that's all right. So I've created this async pipeline. Async pipeline is this object that is able to take a list of a single source and multiple sinks or destinations, and we can start it, which is just going to start the readable. We are wiring events such that every time we read a buffer, this is getting routed to the destinations, potentially multiple. We make sure to ref and unref the buffer properly. And when the buffer is written, we just resume, because why? As we are imposing that all of the readable and writable, actually, I still need this, right? Yeah. All the readable and writable sides needs to have the same buffer pool. When the writing side, it's maybe getting full because it's not writing fast enough as we are reading, then the buffer pool will be exhausted. Once the buffer pool is exhausted, the reading side, as we have seen, will just fail. We will have this get, whereas the get buffers or pause will not be able to get a buffer. So we will be in paused state, and that's all right. We will not be reactivating requests or doing anything. And this means that when the buffer will get written, we will resume. So a readable stream has been implemented using C Async request object, which is an asynchronous object, can also run on a thread pool and so on. So when we get to the first read operation, we just try to get a buffer, set up our callback such that we will get this onRead callback invoked properly with the buffer ID. We're passing the buffer ID as a parameter to avoid storing it here, which we could, but this is saving a little bit of memory. Premature optimization is always good. Then we start the request. Let's say, I like to say more like non-pessimizing it, because probably we're not optimizing anything, but it really doesn't cost much for us to do this. So let's not pessimize it. So in the callback, we just check if we have something good or we have an error. If we are at end of file, we signal the end of file to the state machine. Otherwise, we will just be pushing this buffer and request a new one. If we get a new one, we reactivate using the C Async reactivation method, not the state machine reactivation method. That's important to say. We implement a writable stream in the same way, binding this virtual function-like object and initializing it. We also, of course, pass the buffer pools and the requests pool. Then we write, and when writing this, we are trying to obtain the data and fill it into the request object, which is a file write request. This will be very symmetric for sockets. We'll see maybe in the next video, maybe for sure. Then we start the request, making sure to unref it to ref it only if this is successful. Actually, we could do the same logic here instead of the reverse logic. Oh, that's wrong. Wait a minute. Yeah, because... Oh, no, that's a reverse logic because we need to keep it. Okay. That should be right. And then we unwrap it after we finish writing. We extract the result and signal the finished writing. We have this bogus parameter that is completely useless. I guess I will remove it. But yeah. So that's the test, generate the data, we set up the event loop. It's very verbose, that's a test. I should probably improve the API a little bit, but you see this does not allocate this entire system does not allocate anything. It just requests buffer, even the write queues and the read queues, they are specified by the user. I'm using arrays here. You can allocate with heap memory, as many as you want, as long as you pass them into the initialize. That's what the system is going to use. It will never go outside of that range. Then I create this pipeline with the sink and the destinations, running all of the process and then checking that the data is okay. I guess that was a lot. Hopefully you enjoyed this video, and I hope to see you soon, maybe in the comments. Make sure to check out the Discord and get in touch if you're interested with the project, and have fun with whatever thing you're doing, just like I do. Bye. Have a nice day with Sane C Libraries. Bye.